Welcome to the project of building a highly unique wind-driven airboat. The frame opens with a close-up of the boat, equipped with a powerful V-Twin engine. We are witnessing the highly impressive water gliding performance of this machine. The giant propeller at the rear pushes the boat, making it glide at incredible speeds. The dual-rudder steering system reacts flexibly, allowing for extremely smooth cornering. Now, let's turn back time to watch the assembly process from basic components. Here are the bevel gear and shaft components. 3D printed using SLM technology from 316 steel. The surface finish of the stainless steel is very sharp, ensuring mechanical precision. Next, take out the gearbox casing parts, flanges, and shafts to prepare the drivetrain. Every detail is designed with a modular approach, optimized for assembling the bearings and flanges. The 3D CAD drawing on the software clearly shows the perpendicular meshing principle of the two gears. This structure is responsible for redirecting the drive 90 degrees from the engine shaft to the propeller. The model shows how the gearbox casing encloses the gear cluster, permanently protecting the center of rotation, moving to the mechanical milling and turning process. On the stainless steel components, clamped tightly in the vise, the engineer uses a tap wrench to create internal threads for the screw holes. The tapping process requires meticulousness to create standard thread pitches for a secure connection. Starting to assemble the drivetrain, the roller bearing is carefully driven into the flange hole. The first gear shaft is inserted through the bearing, using a rubber mallet to tap it firmly into place. Next, add a washer and position this cluster into the U-shaped frame of the transfer gearbox. The second bearing is pressed into the opposite flange to support the parallel drive shaft. 4. The second gear shaft is put into position, creating a perfect right-angle mesh. A hand rotation test shows the gears mesh smoothly, without any play or binding. 1. Use hex bolts to tighten the two flanges onto the gearbox body to lock them in place. 2. A thick shaft is prepared, with a flat machined end, to secure the set screw and prevent slipping. 3. Insert the thick shaft into the gearbox and use a hex key to tighten the set screw onto the shaft's flat surface. Now it's time to handle the heart of the boat, the V-Twin engine block with incredible torque. The engine is being dismantled, using an impact driver to remove the cylinder head cover and intake manifold. The carburetor assembly and old intake flange are removed to proceed with measurements and upgrades. Continue using a wrench to remove the carburetor mounting base to customize the air intake path. A high-strength steel pulley is also removed from the main crankshaft using a cordless drill, switching to a stick welder to tack weld the flange onto the Y-shaped intake pipe assembly. Attach the ground clamp to the aluminum housing and spot weld using arc welding, bonding the intake manifold pipe together. Next, wrap a layer of heat-resistant rubber tubing around the outside of the intake to create a flexible joint. The intake manifold assembly is reinstalled onto the engine block, using a screwdriver to tighten the metal clamp to prevent pressure leaks. Reinstall the double pulley onto the crankshaft, then route the drive belt through the pulley in preparation for connection. Use a rubber mallet to drive the pulley into place, then use a wrench to heavily tighten the retaining nut. The striking red electrostatically painted intake assembly is being aligned and reinstalled onto the engine block. An engineer tightens the intake mounting bolts to ensure an absolutely airtight seal. 2. Thread the steel throttle cable through the carburetor lever mechanism to create an RPM control system. 3. Adjust the tension of the return spring to ensure the throttle valve releases quickly when the force is removed. Moving on to the fiberglass composite parts. An N air scoop is being lined with wood. The engineer cuts the wood lining inside the fiberglass air scoop to enhance the structural rigidity. Install the galvanized 3-hole throttle valve mechanism, operating synchronously via a horizontal control shaft. Spray a gray primer, then apply a layer of glossy red paint for this aerodynamic air intake assembly. Mount the completed air scoop onto the carburetor assembly, creating an extremely aggressive and sporty look. Customize the throttle age arm with a red aluminum rod, screwing it accurately into the engine block. Connect the throttle cable and check the elasticity of the spring. The choke mechanism opens smoothly and decisively. 4. The Vanguard engine's protective panels are tightly bolted, showing off the large displacement V-Twin engine block. The ultralight carbon fiber propeller is revealed. Use a rubber mallet to tap the aluminum hub to position the shaft center. Drill the center hole and use a tap wrench to create threads for the aluminum hub to ensure maximum torque transmission. Proceed with arc welding the thick steel shaft to create a permanent high load-bearing connection. Install the V-groove pulley assembly into the 90-degree gearbox. Tighten the bolts to secure the flange and clamp. Firmly weld the gearbox onto the tripod mount. Tubular steel withstands the powerful thrust from the propeller. First, secure the engine onto the mount and assemble the 2 drive belts to transmit power from the engine pulley to the gearbox shaft. Second, start building the plywood boat frame. Cut it with an angle grinder and apply glue to create an aerodynamic flat surface. Fourth, apply fiberglass and roll-on composite resin. Place the PVC pipes to create water guiding channels along the bottom of the hull. Wrap and reinforce the PVC pipes with fiberglass. The flat bottom with water guiding ribs is now complete. Position the engine mount onto the boat deck. Pour composite resin and apply fiberglass to securely lock the base in place. Bend the fiberglass sheet around a large bicycle rim to create a protective cage for the propeller tips. Glue the edges of the airflow guiding rudder panels. Install them vertically right behind the rear protective cage. Use an impact driver to tighten the steering tie rod. The ball joints allow the rudders to move smoothly in sync. First, connect the steel core steering cable to the center lever, converting the push-pull force into rudder steering angles. Second, use a spray gun to apply a coat of gray primer over the entire body and rudders to waterproof the composite. Third, 2 engineers team up to lift the heavy V-Twin engine, weighing dozens of kilos, and drop it accurately into the mount. Slip the 2 drive belts onto the pulleys. A cordless drill is securing the bolts to attach the protective cage to the boat mount. The carbon fiber propeller is installed onto the main shaft. Gently tap it with a hammer and use a wrench to tighten the nuts, ready for takeoff. Connect the fuel line to the carburetor of the powerful Vanguard 18 engine to assemble the front steering mechanism. The V-shaped lever is securely pinned with a pivot shaft and nuts. The 2 rudders. The aerodynamic gray components are dropped into the fan cage brackets. Connect the red tie rod. The throttle cable connected from the brake lever on the front steering stick transmits mechanical signals directly to the throttle valve. Screw in the ignition switch assembly. Connect the wires to the battery to supply starting power. To admire a close-up of the completed drivetrain, the sharp carbon fiber propeller is ready to slice through the wind. The overall custom airboat masterpiece features a matte gray finish, accented with red mechanical details. First, press the start button. The V-Twin engine roars. The propeller spins rapidly, generating hurricane-like thrust. Second, the boat glides on the water with extreme acceleration. The wind thrust makes the hull almost fly across the water. Third, tight corners are handled smoothly, thanks to the instant response of the dual rear rudder system. The point of view angle shows excellent stability. The flat bottom design with guiding channels maximizes efficiency. First, the driver easily masters the machine using the steering stick. The T-stick controls the speed via the hand throttle. Second, perfect machine from blueprint to reality, confirming the power of mechanics and invention.